chapter number 13, that is organic compounds containing nitrogen. And in particular, today we'll be discussing about the basic nature of amines. Okay, so as you are taught, if an organic compound has NH2 group, RCH2 NH2, okay, this is the aliphatic amine, and whenever you have NH2 group in benzene ring, then that gives you aromatic amine. So this is your aromatic amines and this is aliphatic amines. Now today we will be discussing about the basic nature of amines. The basic nature of amines is because of the presence of lone pair over nitrogen. Nitrogen contains lone pair. Now this lone pair of over nitrogen is responsible for the basic nature of amines. Now you have to listen to this very carefully. The more easily this lone pair of electron can be given to other acid containing like protons. Okay? The more easily this lone pair of electron over nitrogen can be donated for protonation, that particular amine will be more basic. So let me tell you once again, the more easily the lone pair over nitrogen can be given for protonation, that particular amine will be more basic. So let's discuss about the basic nature of certain aliphatic as well as aromatic compounds. Now we know ammonia. We have ammonia. So NH3 also has lone pair over nitrogen. Now let's take some methyl substituted amine. Say you have CH3 and NH2. Now whenever you compare between the basic strength of ammonia and aliphatic amine, then you can see here that in both the cases you have lone pair over nitrogen. But in case of aliphatic amine, this CH3 group shows plus I effect. This CH3 shows plus I effect. That means the electron will be permanently shifted towards nitrogen. Okay? That means the density over nitrogen will be more than compared to NH3. That means these electrons are now easily available or easily donated for protonation. Hence, the basic strength of aliphatic amine will be more than that of ammonia. Why? Because here there is no such alkyl group which shows plus I effect. So it has to be very clear. More the density over nitrogen atom, more the electron density over nitrogen atom, that particular amine will be more basic. Now let's compare the basic strength between aliphatic amine and aromatic amine. So this is your aliphatic amine, and here aromatic, as you know, contains benzene ring. In both the cases, over nitrogen there is lone pair, presence of lone pair. Now we have to again compare their basic strength based on what? The availability of lone pair over nitrogen. Now let's see what are the factors that is accounting for its basic strength. So here, as you know, R is alkyl group. This always shows plus I effect. Plus I effect will increase the electron density over nitrogen. Now whenever we come to aromatic compound, that is amine, this is aniline in particular. The lone pair over nitrogen is not freely available as it takes part in resonance with the benzene ring. So this lone pair, you can see it here, resonance I already taught you. This lone pair over nitrogen in aromatic compound is not freely available. These two electrons over nitrogen will be taking part in resonance inside the benzene ring. Hence, the basic strength of aliphatic amine, this is aliphatic amine, will be more than that of aromatic amine or amines. Okay, so this is very important and you have to remember what are the factors that are responsible for their basic strength. Now let's discuss about the other examples. Okay, so let's discuss more about aromatic compounds. Aromatic amines. So now we have to remember here, if an electron donating group is present, electron donating groups, they always increases the basic strength of amine. The basic strength of amines. And if you have electron withdrawing groups, now electron withdrawing groups will decrease the basic strength of amines. So this you have to remember properly. Now let's take an example. Let's take aniline. So here we have aniline, NH2. Now those compounds which contains electron donating groups. If electron donating group is present, electron donating groups, and here you have electron withdrawing group. So here we have not exactly at this position, but in general electron withdrawing groups. Now this, as I told you just now, as I have written here, electron donating group will always increase the basic strength of aromatic amines. So the basic strength of electron donating group present in the benzene ring of aniline will be more than that of aniline, and the list will be those in which electron withdrawing groups are present. So electron donating groups, like you have say CS3 group, you have OR, then again you have OH group, etc. If these groups are present in benzene ring, then their basic strength will be more than that of aniline. Now electron withdrawing groups like NO2, you have C double bond O, you have C triple bond N. If these groups are present in the benzene, then their basic strength will be less than that of what? Aniline. Now let's discuss about Ortho Effect. This is the general trend. Okay. Now let's discuss about Ortho Effect. Now this Ortho Effect you have to keep in your mind. Whether you have electron donating group or electron withdrawing group. If such groups are present at ortho position, then their basic strength will be less than that of aniline. So this is the rule that you have to keep in your mind. What? Whether irrespective of electron donating group or electron withdrawing group, if they are present at ortho position. So you know what is ortho position? You have NH2. Now these two are ortho positions. This position and this positions are the ortho position. Now in this particular position, whether electron donating group is present, any one of this, or electron withdrawing group is present, any one of this group, if it is present over here, then this trend is not followed. you have to remember ortho substituted aniline, irrespective of whether it is electrodonating group or electroneutralizing group, their basic strength will be less than that of aniline, and this is because of ortho effect. So these are things that are very important and often asked in your ISC as well as your competitive examination. So you have to prepare them very well. The basic strength order will be asked. Now let's discuss about the basic strength of first degree, second degree and tertiary amines. Basic strength of first degree, second degree and third degree amines. So as you know, what is first degree, second degree and third degree, you always know it. Now in gas phase, you have to remember, in gas phase, the order of basic strength is third degree is more than second degree. This is that of first degree. Okay, so what are third degree amines? You have say N, you have CH2, CH2 and CH3. So this is your third degree amine. The nitrogen is directly bonded to carbon atoms. Now here it will be say CH2, NH, and here it will be CH3, NH2. Now in gas phase, you have to remember this is very important. In gas phase, the basic strength order is third degree, second degree and first degree. Now this can be easily explained by taking plus I effect of CH3 groups. In third degree you have three CH3 group and they will be showing 3 plus I effect. That means the electron density over nitrogen will be most because of 3 plus I effect. Okay? In case of second degree you have 2 plus I effect, and in case of primary you have only 1 plus I effect. Now because of this difference in plus I effect shown in tertiary, second degree and primary, their basic strength order in gas phase is this particular order. Now whenever we come to now aqueous solution, now in aqueous solution the order that is the basic strength order that is observed is little different. Okay, so let's discuss that. Now in aqueous phase, the order that is observed is second degree, then comes third degree, and finally the list basic strength is primary. Now this particular trait in basic strength can be explained by two factors. The first one is steric factor. Steric factor. Now steric means this when the size is bigger, okay, then in that particular case what happens is the repulsion will be maximum. So you have to remember this steric factor. In case of tertiary you have maximum steric factor. Why? So let's explain it with an example. So you have CH3 and CH3. In this case you can see these CH3 groups are bulky groups. Now since they are very crowded or around nitrogen, they tend to remain as far as possible from each other. Because of this, its stability is least among second degree, third degree and first degree. now whenever you consider only the steric factor, then the basic strength order would have been first degree, second degree, then third degree. Why? Because in case of tertiary, there are three bulky groups, they are repelling each other to the maximum extent, and because of which its stability is low. Now, if the stability is low, their basic strength will be minimum. So this is one of the factors, that is steric factor. Now let's discuss about the next factor, which is very important, that is solvation of iron. Now please remember, because of the steric factor, the trend should have been first degree, second degree, and third degree. Now let's discuss the other factor. Solvation of the iron. Number 2 factor is solvation of iron. Now, whenever amines are dissolved in water, what happens? The nitrogen atom of the amine forms hydrogen bonding with the hydrogens of water molecule. Now, as a result of this, so let me tell you once again, when an amine is dissolved in water, then the nitrogen atom of the amine, they form hydrogen bonding with the hydrogen atoms of water. And because of this, you have to remember that energy called solvation energy is released. Now, this bonding energy, because of its stability, because of the formation of hydrogen bonding energy is released, which is known as what? Hydrogen energy. Okay? Now what you have to keep in your mind, more the energy released, more will be the stability, and more the stability, the basic strength will be maximum. So you have to remember this particular factor. Okay? Now, say, whenever you have protonated amine, then in such cases, energy will be released, and let me show you hydrogen bonding. Hydrogen is present, and hydrogen is present. This is positive, and here, now this hydrogen of amine will be bonded with oxygen of water molecule. There are 3 hydrogens, so you will be having 3 hydrogen bonding. Okay, now whenever we consider solvation of iron, we come to know about hydrogen energy. More the energy released, more will the stability, and hence that particular amine will be more basic. Now whenever we combine these 2 factors, steric factor, solvation of iron or hydrogen energy, and also account of plus I effect, inductive effect, we come to know that the basic strength trend is second degree, third degree, and then this is first degree. So this is actual basic strength of amines. Okay, when we count for the combined effect of steric and solvation of iron. In liquid phase, so this is in aqueous phase. Hope this is clear. Now we'll be continuing in the next class. Till then, keep revising. And if you have any problem, you can ask me. You have my WhatsApp number. You can ask me. Thank you.